Hi everyone, I'm Alec Stewart and this is my Cisco ASA talk. So a little background on myself. I'm from Sydney, Australia. I work in the firewall or network security design space. Not really a security researcher by trade or anything like that. I worked as a firewall engineer for a long time. And in that space, I was working with Juniper and NetScreen and Checkpoint. I never really had any Cisco ASA exposure. So I ended up buying a Cisco ASA off eBay and just started having a poke at it. And pretty much this is how the talk came about. So little disclaimer before we get into it. Like I said, I'm not a security researcher by trade. This is not really related to my job. It's actually helpful that in my job we don't work with any Cisco ASAs. I did this purely for security research sake in my own time, for fun basically. All the vulnerabilities have been reported to Cisco, so I did this talk back in October last year at RuxCon down in Melbourne, Australia. And at that time, all these vulnerabilities were pretty much 0-day. I'd worked with Cisco up to maybe 4, 5, even 6 months prior. And so Cisco had delayed their release of their patches up until about 3 days before the RuxCon talk. So it was quite nice of them to do that. So everything was pretty fresh. The patches are available if you have Cisco ASAs that are still unpatched. All these pretty pictures are from the internet. So what we're going to do today is step through the little Super Mario world. So first of all, we're going to get some local shell access, and we're going to look at maybe putting in some persistent malicious firmware onto the Cisco ASA. But I mean, having a rootkit, if you like, of the Cisco ASA is not really useful unless you have local access. So to get that, I've decided that we need some remote exploit to get access to the ASA to put our rootkit on there. So we're going to do that, but our remote exploit doesn't give us any access, I guess, to the device itself. So we need to use the credentials that we capture from our remote exploit to then compromise the device. And finally, I mean, we're not really here to just own the firewall. When you want to own a firewall, you generally want to own the data that it's protecting or the networks that it's protecting. So that's what we're going to do. We're going to essentially own the network, and we're going to own the network via the functionality of our rootkit. So that leads me into why do we want to own the firewall? Well, the traditional reasons are quite simple. Like, you own the firewall, you can change the firewall config, you can open up the network. The firewall is the gateway on the network, so it's a perfect place to sniff traffic or man-in-the-middle traffic. But the reason I want to own the firewall is none of these real reasons. It's because, if I can own the firewall, I can change my traffic as it passes through the firewall. So this is going to allow me to basically blend into the network. And the reason I want to blend into the network is because we've moved away from the idea that, you've got a trust and untrust on the firewall, and that basically everything outside the firewall is untrusted and everything inside the firewall is trusted. So, there's a big increase these days in, detection and response on your internal network. So you've got things like network security monitoring and SIEM. So basically my idea is that if we can own the firewall, what we're going to own is the rule base. And the rule base basically tells us the trust relationships of entities on the network. So the rule base from the compromised firewall actually describes the expected network traffic patterns that you would expect to see on the network. And therefore, maybe what we could do is we could rewrite the firewall rules that we've captured as NAT rules. And this will allow us to send our traffic through the firewall and then get natted to be the allowed or expected traffic. So I'm calling this technique man in the wall. I don't know if that'll catch on, but it's kind of an interesting space between, I guess, IP spoofing and man in the middle. So let's have a look at what the Cisco ASA actually is. So it's it's a black box appliance, gets sold to you, and it looks quite fancy. It's got big blue box, but underneath, really, all it is like a high spec Intel server. So we got two different modes, I guess, of the hardware or generations of the hardware. You've got the legacy hardware, and this is what you would find in a lot of networks today. And it's basically just 32-bit Pentium 4 hardware. Right down the bottom there is the hardware that I bought off eBay. It costs, maybe $200 or so. It's a 5505. It doesn't have a lot of RAM. That CPU is just like a small form factor Intel 32-bit CPU. So the reason, I had this little device is because it's affordable. It's like $200. But the good thing about it is it actually runs the same firmware image as the high spec, maybe the 5550. And I'm not talking about running the same version of software. It'll actually run the exact same firmware image. So that's important because it means that if I find a bug in my little $200 appliance, I'll find the same bug in, the $50,000 appliance or whatever it is. So Cisco are slowly phasing out that legacy hardware, and they're introducing the next-gen hardware. So this is basically just 64-bit CPUs, Intel once again, a lot more RAM, far more powerful boxes. What's interesting is Cisco's also released a virtual ASA, and once again, it runs the same firmware image as the actual hardware, the next-gen hardware. So it means that if we find a vulnerability or a bug in the virtual machine, it's going to run on the hardware. So that's the hardware side of things. When it comes to the software, the Cisco ASA is much like the Cisco iOS in terms of the CLI. So you've got a couple of modes. You've got basically a non-exec mode where you can't do anything. Then you go into like the enable mode, and you can do like show run, show interfaces, show version, show IP, route, whatever. And then you can go into the config mode, and this will allow you to set IP addresses, change the access list, add your NAT rules, whatever. Of note is that the persistent storage is on compact flash, and it's called disk 0. There's another mode of configuring the ASA, which is using a GUI called the ASDM GUI. And basically, it's like a Java program that runs sort of out of the browser, and it basically wraps all your actions in the GUI into HTTP posts. And it basically just does the same thing as the CLI, but you get a nice GUI. So one of the show commands in sort of the enable mode is show kernel process. And when we look at the show kernel process output, we can see it's pretty familiar, just a PS list. And it sort of tells us that there's an underlying operating system. Like, we're in this restricted shell, and everything seems like, you can't do a whole lot. And then you realize that, oh, hang on a minute, there's a completely different operating system running underneath this Cisco thing. So we go on the internet, and we have a look at these PDFs that Cisco have provided, which basically show all the open source projects that are wrapped up inside their firmware. And there's like hundreds of projects in the firmware image. Cisco actually, because it's GPL and all the rest of it, they'll actually provide you with the build root of the open source code, which is nice. It's kind of like the open WRT sort of project. They'll give you the build root. So if we grab the firmware either from the device or we download it from Cisco, we run it through the Binwalk tool. So I imagine some of you guys are familiar with Binwalk. It's basically something that will analyze patterns and signatures inside firmware images, and it'll try to extract it if it can find it, whatever it may be. So we run Binwalk over our firmware image, and what we can see is there's something in there called rootfs.img. And this is like just a gzipped CPIO archive. So CPIO is like tar. It's just a really generic sort of archiving format. So we can extract the rootfs.img from the firmware image, and then we can just extract it using that command down the bottom. And you can just see that we get an outline of, well, we get the offline version of the file system. So we have a look at the file system, and it tells us that essentially this is a really basic Linux environment. And most importantly, the directory /ASA contains all the Cisco files. So when we analyze the offline file system, we can see the boot process, so we can have a look at what's in the init tab and the RC scripts. And we can see that basically the whole function of the Linux environment is to boot one single executable, which is called ASA bin liner. So ASA bin Lena is the actual firewall. The whole Linux environment only exists for that process to run. So if we look briefly at the Linux environment, we can see it's pretty basic. It's got like ASLRs disabled, we can load LKMs, it's got a nice GDB server for us, and it's got ptrace support. But it doesn't actually have any access to the network. So, if we get to the shell in a running environment and we do ifconfig -a, we've got like 3 interfaces that really don't do a whole lot. Dummy, loopback, and a tap. So it's like, well, what happened? We've got this piece of hardware that has all these interfaces on it, and none of them are exposed in the Linux environment, which is kind of strange. And it turns out what's happening is that that ASA bin Lena, the firewall, wrapped in an executable, actually has user space PCI drivers. So within user space, it's actually handling everything off the wire, which is kind of interesting. I hadn't actually seen much in terms of user space PCI drivers before, but yeah, it's apparently not that uncommon these days. So does that mean that we don't have any access to the network from the shell? We get access to the shell perhaps, and then we can't actually get access to the network because there's no network interfaces. Well, it turns out that, by digging in the ASA directory, we can have a look, and we see that there's references to these LD preload libdsocks library. So libdsocks is like an open source program or project called Dante, and it's, I guess, sometimes referred to as Soxify. And it basically forces an application's calls to connect to the network and wraps them through a proxy server. So that sounds pretty interesting because, suddenly we might be able to access the network from the shell. So it turns out that there's like a hidden SOX proxy that we can enable in Lena via the Cisco LAN CLI by going service internal, loopback proxy server. And suddenly the loopback interface that we saw earlier has a SOX proxy running on it, which then we can access to the network. So what we really want to do is we want to subvert ASA bin Lena, because that is the firewall process. So there's 2 ways that we can do that. First of all, we could modify the firmware image so that we modify the binary, like the ASA bin Lena, before it starts up. Or we can maybe jailbreak from the running version of the ASA bin Lena and then modify the running process. So first of all, we'll have a look at modifying the firmware. So, what we could do, like this, it's really quite simple, is we could just modify ASA bin Lena, patch it here and add some code there, and then just repack it using CPIO, which is, on pretty much every standard Linux platform. Gzip it up, open up the firmware image, and then just paste it right over the top of the old rootfs.img, and then we could just load that onto the ASA. But when we try to load it onto the ASA, we get this checksum verification failed. And that kind of sucks because it means that, obviously there's going to be some embedded checksums here or there inside the ASA image that we need to find and replace. And so, yeah, when we try to upload this using TFTP or FTP from the ASA prompt, so basically copy from TFTP server to, the device, then we get this checksum error. So, like I said, we could rewrite all the checksums because it's just checking itself. So we could rewrite, at the locations inside the firmware, or we could just bypass that check altogether by just SCPing our malicious image to the device. Because for whatever reason, that check isn't done if we SCP our malicious firmware up onto the device. Now, Cisco could go and patch this. It'd be really quite simple for them to do. But it doesn't, that would be a cosmetic patch because, even if they did just patch it so that it did the check when we upload a malicious version, it doesn't stop us from rewriting the hashes inside the image. So essentially, when we reboot the device with our malicious image loaded, the boot process doesn't run that verification at all either. And I emailed Cisco to ask them what they thought about, the verification process. Because I realized I was loading a malicious firmware onto my Cisco ASA without any issues. And they basically said that, the checksums that are built into the image are there to detect sort of corruption during file transfer. It's not there to offer any security at all. So, this issue apparently has been fixed on the new versions of the hardware, so that next-gen hardware because it's got, like a secure boot. Hopefully that is the case. I haven't tested it. I don't have any access to the new hardware. But in the old versions of the legacy hardware, this lack of integrity verification has been exploited for, well, at least since 2008. So I don't know if you guys have seen the Spiegel releases of the Ant catalog, which came out of the Snowden leaks. So essentially, the NSA have been building, implants for all these infrastructure devices like Cisco, Juniper, NetScreen, and a whole bunch of other, network infrastructure devices, and they've been doing it for quite some time. So they built this one called Plow, which is described as a firmware persistent implant, which is kind of interesting because I think the Screenos, which is the NetScreen one, and the SRX ones, I believe, were BIOS persistent. But for whatever reason, they stuck with firmware persistence in Cisco ASA. I guess they didn't have access to the BIOS. So what it does is it modifies the Cisco Firewall operating system at boot. So that basically it becomes, part of their greater botnet, I guess you'd call it. And you'll note that the versions that it runs on are all the legacy versions, including my little 5505, because like I said, the same image is used across all the platforms. So what we're going to do is we're going to make our own Plow. So what we want to do is we want to change the startup method so that it does what the the NSA does, and it modifies the operating system at boot. So what I do is I'm just going to pack in my own little init script. I'm going to have like a little binary infector to infect ASA binlina. I'm going to have something running in the background for persistence so that if an admin tries to upload a new version, it's going to infect that essentially. A little something for stealth, a little kernel module, and then just a generic reverse shell for communication. So what I do is I get all those files, and without really changing too much in terms of the structure of the image, I just put all these files in and just do gzip -9, which gives me more compression over the original rootfs.img image. And I just put that back into the firmware, upload it. Of course, I'm not cutting and pasting it anymore. I've got like a little bash script to do it for me. So this is basically just carving out the rootfs.img, putting my files back in, and then gzipping it up, and then putting it back into the original firmware image. So what we're going to do is we look at infecting Lena. So this is a really simple program here. All it's going to do is create a new menu option called Show Mario Logo, and then he's going to put some ASCII art on the prompt that'll just stay there. The admin can log in, and he'll just see Mario sitting on the prompt there. Really innocent example. Could easily be weaponized to do anything to the firewall. Next up, we're going to put in our little persistence program. This runs in the background, and originally I wrote this thing so that it would automatically infect sort of new firmwares that were uploaded, but it was just too slow because it's like compact flash. My device, I don't know how old it is, I got it on eBay, and it was just the I.O. for just extracting, un-CPIOing, and then putting it all back in and gzipping back up. It just really resource intensive on the disk I.O. So in the end, I just changed that so that it would actually just trigger, when a new firmware is uploaded, it would just go and grab a firmware, which would be the Trojan version from the pretend CNC server. So next up, we have something for stealth. This is really simple LKM. So the Linux kernel version that runs on the Cisco ASA was pretty much, or still pretty much is standard from, version 8 or something. So it's like 2.6.29. So it's getting on in age. So writing a LKM rootkit was really simple. And all my rootkit does, or my LKM does, is basically just redirects the open call to basically open a clean version of the image. So it's going to open up the image that the admin uploaded. So it means that our stealth or our infected or malicious binary is going to sit where it's meant to be booted from, but then every time the admin goes to access it, either to do a verify command in ASA, or even to download it back onto his computer, maybe he thinks that there's something strange going on, so he wants to take it offline for analysis. So he's going to request firmware.bin, and he's going to be given the same version that he uploaded, completely clean, unmalicious. Next up, we've got like a really simple reverse shell. So remember I was talking about the LD preload before? So basically, I'm just using SOCAT as my reverse shell sort of technique, and I'm just LD preloading libd socks so that basically when we do our reverse connect, it's going to connect to that IP address there, 192.168.1.106 on port 4444, and it's going to bounce out from the shell via the internal proxy, SOCKS proxy, and out to my CNC server. So a little demo of a malicious firmware image on the ASA. So here, dir bin, you can see that this is the only image that's on the file system in Cisco land. We're going to run, just show that that is the image that's going to boot. Now I'm going to verify that image. So that image comes up and, it says that that's the SHA-512 hash of it, ODBF53, blah, blah, blah. We go across to the Cisco website, and we can see that that matches. So that looks like a perfectly fine piece of software that's going to run. Signature's been verified, whatever that means in terms of signatures, but all right. Now we're going to load that particular piece that we've just verified, that firmware, and sure enough, it's loading this infector, which is changing a few things here and there. It's installing the LKM, which is the kernel module, and it's starting the background upgrade infector. So the thing is booting now, and I've got my little netcat listener here where my reverse shell is going to pop up, and log in, and I type the command show Mario logo. It says this Cisco ASA, you can read it, and it puts a Mario on the command prompt there. And sure enough, we get our reverse shell. So just do some basic PS there to show you that the background thing is running. And then I'm going to jump here to the admin console, pretend admin console. I'm going to pretend to upload a new version of the firmware. So this is ASA 924, so it's an upgrade from 921. This actually isn't the real file. I was recording this, and I'd done a bunch of test files, so you'll see the concept is there, but you can see it's only like a really small file. Unfortunately, I didn't pick that up until, I'd already finished. So you can see there that the upgrade process running in the background has detected that a new file has turned up on the file system, and basically it's gone to the CNC server and it's downloaded the same version of the file. So that is pretty much a completely compromised firewall. So that's one way of doing it, but it requires a reboot, and it's not going to work on the new hardware because new hardware has secure boot, TPM, and all the rest of it, apparently. That's what the asterisk is there for, because I haven't tested it. But a nicer way of doing it would be to actually jailbreak from that restricted CLI and then patch the running Lena process in memory. And this way we don't need to reboot, and we basically bypass all the integrity checks, so secure boot and all the rest of it. And obviously this would work on the latest hardware, although I should have put an asterisk there as well. So here's a little jailbreak vulnerability that I found. We go into the Cisco LAN config, and we do vnmc policy agent shared secret, and then we just wrap our whatever shell command or whatever Linux command we want to run inside ampersand. So this is typical sort of tainted input. So we could have done like backticks or whatever you like there. Not pipes, because pipes are used in the Cisco CLI. So we do our backticks there, and it's just basically going to run that reverse SOCAT shell to basically give us another reverse shell. So this is kind of good because the shared secret is actually a password store. So Cisco will actually replace that mount disk 0 with asterisks after it's in. And because it's part of the config, it's actually going to run that at boot every time. But if the admin logs in, he's going to look at it and it says shared secret asterisk asterisk asterisk. It's not, as obvious as mount disk rev.socat.shell. So, there's a potential here that you could use a vulnerable version, say this 9.21 actual firmware, to then, launch a bootkit on newer versions of hardware. Because, if you look at things like DRM with PlayStation or Xbox, where they had one bug, and it's one bug can essentially just undo the whole work of a trusted boot sequence. So maybe it could be used here, I don't know. So this is a little demo of the jailbreak. Got our netcat listener there again. We type in our shared secret thing, and suddenly we get a nice little shell. And you can see the version there of Linux, and not too much else. So that's basically our jailbreak. So this has given us, access to the Linux shell without a reboot. And we've also had a look at how we could do, persistent rootkits with, reverse shell access. So that gives us our first little entry. But we need some sort of way of getting our rootkit or malicious firmware onto the device. And we could do that either by, you have a malicious administrator, captured credentials, and, someone already on the network. You could have supply chain interdiction, which I had to look up. Apparently it's a military term for interception of, parcels and basically loading malicious stuff, firmware specifically, I guess. Or we could have a remote exploit. So this is also from the Edward Snowden leaks and the Der Spiegel article. This is some NSA employees basically at a shipping center where they would load on their malicious firmware onto Cisco equipment and then send it off. So I don't have those kind of capabilities, but maybe we can find a remote exploit instead. So there's going to be two candidates for a remote exploit. And they're going to be in the application protocol inspection or within services that the ASA runs. And the reason for this is because if you look at the evolution of firewalls over time, they're actually starting to become more exposed to user input because they're running things like application protocol awareness, even things like IDS, IDP, which are trying to analyze essentially traffic which is defined by the end users. It could be malicious. And so we've moved on from the old days where, the firewall just looked at source IP, destination IP, and destination port. So if we look at the protocol inspection, Cisco's had a pretty shaky history. All the stuff in red is memory corruption and protocol inspection bugs, usually resulting in denial of service attacks. And it looks like pretty much every application layer that they've tried to analyze has had some sort of CVE. And these are mostly denial of service attacks and not exploitable. So one of them, which looked like it was not a sort of heap-based overflow, but a stack-based overflow, was this one that sort of caught my eye. And it was an unauthenticated remote stack overflow in the RPC, Microsoft RPC inspection. So we know that ASLR is disabled because we can tell that from our shell access that we've got. And from the shell access, we can actually see how to start Lena waiting for a debugger to attach. So we can get a pretty good look at the inner workings of the ASA. So I started looking at this particular bug. It was an old bug. I didn't find it. I think ISS found it in 2012. But they didn't give any information. They just said, it's in the DCE RPC inspection, and that was it. So I did a little sort of digging around, and I fuzzed a little, and it turned out that a packet which was in the remote create instance response would cause a buffer overflow. So I got this nice sort of override of registers, and the EIP right there is, looking great. Unfortunately, if you look at the Wireshark thing up the top, you can see that what it's overflowing with is like an IP address, which is 99.99.99.0000000. And so 30 is ASCII for 0. It meant that I was stuck with, only being able to use valid ASCII numbers or the dot, which make up IP addressing in string format, to, overwrite the address. So, I mean, maybe someone could look into it and see if there's like a partial override or a, ROP opportunity. But for me, I was like, oh, it seems, almost impossible. I'm going to move on. So my next port of call was to look for something a bit fresher and something that was in maybe the web VPN portal. So the web VPN portal, you can see, has had a bunch of bugs over the recent times. It's basically an access method, like a portal-based access method to your internal network via your Cisco ASA. But what it means is that it means that you have to have a web server running on your firewall, which is, probably not what, firewalls were originally designed for. But anyway, the ASA has 2 web services. It's got one for that GUI program, which is the ASDM GUI for configuration. But I'm going to assume that we don't have any access to that, because obviously the first thing an admin does is he locks down his management stuff to the management interface or the management network. But we would have access to the web VPN portal / any Connect gateway services, because they are exposed to the internet. So this is what the web portal kind of looks like from the outside. Then on the inside, you can go there and you can basically log in and you can access internal web resources. You can launch like little Java programs that'll give you access to terminal services or SSH sessions. So there's a lot of server-side programming going on to support a web service like that. So if we just simply do strings on the Lena binary, you'll see that there's 86 plaintext Lua scripts that are providing the backend server-side functionality. So I had a look at some of these Lua scripts, and one that sort of stuck out was this one that said check an ASDM session. So it's basically checking whether or not a cookie is valid. And all it's doing is it gets to the bottom here and it goes, all right, I want to see if I can open this file to see if this file exists. And the file has to live in a directory called ASDM, and then it'll just basically have a long string, which is, a random sort of cookie. So if that file exists, then the session is validated. So this looks like it's a perfect opportunity for a little directory traversal, and I just give it a file that exists across all versions. So this is like a Russian translation file that I'm giving it there in the white. So we just check whether or not that file exists, and it always exists, and we bypass the session check. So I'm like, all right, that looks great. Where is this being used? And it turns out it's being used by the Web VPN customization editor. So the Web VPN customization editor allows you to customize your Web VPN portal to change it from the default one that looks like that to maybe something that looks more like your company, like this. So to do this, you need to go into the ASDM GUI, and obviously as the admin, I go in to the ASDM GUI, and I basically change my pictures and my fonts and my text, and I press the preview button. Now, the preview button is very important because it actually creates that ASDM directory that we need to traverse from. So essentially, the bug doesn't exist until a preview has been run. So, I mean, although there's a lot of vulnerable versions out on the internet, because the admin has not run a preview, then they're pretty much safe. So what's interesting is that I can actually generate a preview of my own content by using the bug via the internet-facing interface, not the ASDM sort of management interface. So from the internet, I can essentially do a big post of all the stuff that I want to see previewed, and then basically see what that preview looks like. So what's interesting is that the bug allows us to save that preview as well. So there's another URL that basically goes and says, all right, I like that preview that you've just submitted. Now save it. So this all can be done via the internet-facing web service. So we can actually customize our own preview it, and then we can save it. So we can customize the web portal to, dish up some malware, whatever you like. But what I'm going to do is I'm going to essentially change the form action of the HTML form action. So it's going to post the credentials to my service and not to the ASA itself. And then once the user's logged in, because we can customize not only the login page, but the internal portal, I'm going to have a little JavaScript cross-site scripting to take their session cookie. So I wrote a Metasploit module for this, because it's kind of tricky, because you actually need to scrape down all the current content, because your preview is going to overwrite what the current login looks like. You need to scrape it all down so that you can write it back. So that's what the first step is. Then we request the preview, and then of course we save the preview, and then we just sit back and we wait for our users to log in, and we grab their credentials. And last of all, in my demo here is what I'm going to do is I'm going to start an SSL tunnel using the captured credentials. So not only does the ASA provide like this web portal-based VPN thing, it also has a traditional SSL client-based tunneling capability. So what's interesting as well is the customization that we're going to save gets hidden in a part of Flash that even if the admin reboots or upgrades the firmware or does a factory reset, I think factory reset may get rid of it, I'm not sure. But yeah, if he upgrades it or reboots it, it's still going to be there. So this is what we're going to do. Essentially, we're going to rewrite that form submission action. So it's going to send the credentials to 10.6.6.6. So this is the demo of the Metasploit module. So here it's gone and it's scraped the current settings, and then it's gone and it's saved it. It's checked to see that it's actually been successful, and now it's just going to sit there and it's going to wait for a user to log in. So along comes the user Toad, and he's going to log in with password Toad123, presses the login button, and sure enough, our Metasploit has caught those credentials. And we've also got his session cookie. So we're going to use his session cookie now to basically use the open source version of the AnyConnect client. So AnyConnect is the Cisco SSL VPN client. So we're going to use the open source version, OpenConnect, using the cookie credential. So even if they did have like a one-time secure ID pass or something on the login, because we're going to use their cookie credential to log into the VPN, we should be fine. So sure enough, we've now established a VPN to the ASA, and we've got like a tunnel interface there on Linux to then explore further into the network. So this brings us to the next step. This is what we've done. However, we've actually got access now through the ASA device. We don't have access to the ASA device. So we've just basically got Toad, username Toad, password Toad123, and he can log in and he can maybe access resources internally in the network, but he of course doesn't have access to the management services of the ASA itself. And if we started probing the network as Toad, we might run into like a tiered firewall, or the IPS might trip up, and we might get blocked. So what we need to do is we still need to compromise that ASA so we can understand the expected behavior on the network so we can blend in. So that brings us to the next step. We want to, compromise the actual device. But before we do that, we look at a little reconnaissance sort of phase, another little bug that I found, which basically returns, spits out the firmware image, the firmware version that's running on the ASA. So I wrote a little mmap script that'll basically go and scan and tell you the version of ASA that's running, because it basically just leaks it out of that URL that was on the previous slide. So here, in my fictitious, Bowser Mario land, I can see that I've got two adjacent sort of IP space ASAs running the same version. So I'm going to assume that this is like a typical enterprise configuration where you have a redundant pair. So I was thinking, well, maybe, I can't send traffic to the ASA itself, because, I'm just Toad, but maybe I could send traffic through the ASA to the other ASA. So that was my theory. And it kind of looks like this. Turns out we can actually send these packets that terminate sort of at the primary or the active ASA, and then we can traverse the the failover link, and we can get our packets to reach the standby ASA. But we can't log on, we can't reach sort of the SSH services or admin services. But what we can do is we can have a look at what's expected to live on that failover link. And it turns out you've got these 3 protocols. They're all proprietary protocols. There's no RFCs or anything for these. You've got protocol 8, which maintains state between the firewalls. And I was thinking, oh, this would be really good if I can, inject some of these protocol 8 packets, because then I'd be able to write state into the firewalls and then basically bypass any firewall rules, maybe get admin access onto the device. But that wasn't the case. But it turned out that I can actually send these protocol 105 packets. And protocol 105 does synchronization of config between the 2 devices, and it also allows you to do this command replication. So basically, when you type a command on one ASA, it'll replicate it across to the other ASA. So so this is what we need to do to get that command to run on the second ASA. We do failover exec standby, where we want to execute this command on the standby version, standby firewall, show version. So this will print out the show version output and run that command on the standby from the active firewall. And we can actually do this in the reverse. So if we can, log into the second ASA, we can, execute commands onto the active ASA, and we'll get, that output as well. So the packet format that does this is really quite simple. And you can see in the yellow down the bottom there, that's the show ver command. There's no, authentication built into these packets. There's no real sequence numbers. There's one there, but you can just replay these packets and they'll run the same command over and over. Now you can secure the failover link, but it turns out that it basically is ignored if you use the Cisco recommended way of securing the link, which is basically to set up a tiny little IPsec tunnel between the 2 ASAs. When we send our packets, our customized packets, to suddenly start executing commands, the Cisco ASA will treat the packets that it's received as if it already decrypted them. So we just send plain text packets, and it will just accept them. Of note is that there's no logging enabled on the standby firewall. So even we've got all our logging turned on the active firewall, so we've got, SNMP traps or syslog going off to our SIEM. On the standby, by default, there's no logging enabled. So it means that, if we can start configuring the second ASA, we're not going to generate any logs. So here's like a little demo of me sending some of these 105 protocol packets. And what we're going to do is we're going to download a copy of the running config. Remember I was saying what we want to do is we want to understand the network that the firewall's protecting. To do that, we need to download a copy of the current configuration. Then what we're going to do is we're going to upload our own configuration. And that upload is going to have our new user called Mario in it. And we're going to add our IP address as a trusted IP address so we can actually SSH into that standby firewall from the internet. And then we're going to log in, and we're going to use that failover exec active command to then basically run a command on the active firewall. So this is what this looks like. This is my SCAPI script, and this first command is going to copy the running configuration to my evil TFTP server. So my evil TFTP server is 10.6.6.6. So you can see that that has now it's come down. And now I'm going to create my config that I want to upload. So this config is quite simple. It just basically says create a user called Mario, password card, highest privileges, and add my IP address of 10.6.6 as a trusted IP address on the outside interface so I can SSH in. So now we say, all right, copy from the TFTP server into the running configuration this config that I just made. And so there was a before and after view there of, whether or not my config was there. And so after I've done that command, sure enough, my configuration is now in the standby ASA. So I log into the standby ASA, and I'm going to execute 2 commands. The first one says show failover on my current logged in session, which obviously says that I'm on the secondary ASA. And then I'm going to do that failover exec active show failover include is basically grep this. And you can see there that I've now executed that command on the primary or the active ASA. And so that brings us to the end of that. We've pretty much logged in and we've compromised both of the Cisco ASAs from essentially remote. So what we want to do now is we want to start looking into actually owning the network. And what we want to do is we're going to use that config that we downloaded to understand the network and move into our lateral phase of attack. So like this slide that you saw before, if we started trying to probe the network directly, we're going to get caught out. Whereas if we look at the stolen access lists, we can see that, what is supposed to turn up on the network. So these access lists look like this visually. Basically, anyone on the internet can access the web servers on web server ports. Anyone on the internet can access the mail server on the mail server ports. Likewise, the web server can access the DMZ database server on the SQL port, and our mail server will say is Exchange, and it needs access to the Active Directory on Active Directory ports. So what we want to do is we want to upload NAT rules that are going to change our source address to match what those flows are supposed to be. And this is like pivoting without us actually needing to compromise the mail server, for example. We're just going to, if we had 1,000 different firewall rules in there, we could create 1,000 different NAT rules, and all our traffic would be designed so that it would basically become what is supposed to look to be on the network. So in this example, if we wanted to get, to the DMZ database server, with our NAT configuration, we would change our IP address to be that of the web server. And likewise, if we want to get to that Active Directory server, we're going to change our IP address to be that of the mail server. So here's a before and after view. And I've actually made like a little log server program up the top here. So this is a Bowser log server. And he is basically going to, he's going to pop up when he sees something malicious. So you can see here I've run nmap against the Active Directory server. And, our IP address is the one that we've been given from the SSL VPN, and Bowser's gone crazy, he doesn't like it, and, everyone freaks out. So instead, what we're going to do is we're going to create some config. Our config is going to disable some logging on the active ASA. Obviously, it's not going to we don't have any access to turn off logging on the internal ASA. But, all right, what we're doing here, we're creating our NAT rules, and we're logging into the standby ASA, and we're going copy from the TFTP server into the running config, this config that I've just made, the NAT config up there. So that's going to be now in the active ASA. So now we're going to run our nmap again. And we run the nmap, and you can see here we're now going through the DMZ internal firewall. We've passed through the external, the firewall without any problems, and we can see that the services are open and Bowser didn't pop up, so everything looks great because our IP address is no longer 192.168.100.1. It's the expected address of the Exchange, the Exchange server. So that's all looking pretty good. So it's looking good until our admin logs in and our admin says, hang on a minute, what are all these NAT rules doing on our firewall? So what we need to do is we need to use that original jailbreak to get down to the shell, modify the Lena process so that we hide our NAT rules. And from ptrace and manipulating the binary the in-memory Lena, we could pretty much change any function on the firewall. But all I'm going to do in the proof of concept is basically hide our NAT statements. So we're getting really Mario-like here. And we got Bowser's Castle up there, and we want to access the Active Directory server on port 6666. That's going to be our goal. So we have in the middle our admin view. So this is, say, on the console. Down the bottom, we've obviously got our Mario attacker view. Up the top, we've got our Bowser log server running. So first of all, we're going to make that jailbreak config to give us that reverse shell. So this is, of course, the config that I talked about before, the shared secret with the ampersands that are going to run that. And then we're going to log in to the standby firewall. And we are going to, I think we're going to copy up SOCAT, make a directory to store SOCAT in. We're going to put SOCAT onto our sort of hidden directory there, I guess. We're going to upload the rev socat.shell. And then we're going to copy that configuration into the running config. Or actually, sorry, first of all, we're going to upload this program called Cisco ASA hide nats. So this is the ptrace program that's going to open up the running Lena process, patch it at a couple of spots, and then disappear. So we upload that one. And finally, we upload our reverse shell config into the running config, and that should pretty much automatically drop us into our shell, which it does. And so from here, if we're running, make sure that we're root. We check the PID. You can see Lena there is 1236. Okay, admin view, show run nat shows us the nats that are configured on the firewall. Obviously, they're the dodgy ones that we put in. And then show nat as well as another function, which shows sort of the active nats. So we go down to our attacker reverse shell. We do Cisco ASA hide nats hide, and basically it just patches. And this is like essentially like a hello world version of sort of our introduction to ptrace. All it's doing is just knopping out little bits of memory to essentially not print out hide nats. To not print out the nats. So if we go back to the admin window now, and we do show run nat, obviously our nats are gone. And we do show nat, and we can see that Mario has hidden all the nats. And last of all, what we're going to do is we're going to do some nmaps to show you that essentially, even though we don't have any nats configured anymore, the nats are actually still there. So to do that, we're going to do some nmaps. And you can see that our IP address is being translated. It's no longer 192.168. It is the address of the Exchange server. And we can see that we've got access to the Active Directory server, and we're just basically going to reach out to the Active Directory server on that port 666, which is our sort of end of the talk port. You can see that our IP address is, of course, 10.55.77, which is the Exchange server. Just press a key, and we get our princess from the castle. So that's pretty much it. We've gone from, pulling the firmware image out of the device and analyzing it through to complete compromise, I guess. And yeah, that's our sort of final castle. In the conclusions, I guess we've got to understand that, even when you buy these devices or these appliances from vendors, they sell them as if they're hardware, they're special. But really, they're just software, and they're very familiar software in a lot of cases. Like, Juniper is FreeBSD based, and Checkpoint is usually running on a Linux platform. The fact is that these things are very familiar to security researchers and to attackers. So you got to understand that your infrastructure is a target. And the NSA's sort of work into implants show that it's it is the obvious place for you to attack, because not only is your firewall usually exposed because it's sitting on the edge of the network, it's actually running a lot more services these days and doing a lot more inspection, and of course exposed to user input. So I guess if you look at the bugs that I presented here today, there's nothing really too technical, like simple web bugs. Command injection, nothing really that difficult. It makes you question whether or not, these companies that are tasked with securing other companies' infrastructure are really, offering the highest standard that you would expect for the money that you pay. So I guess, yeah, that's about it.
All right, thank you, Alex Stewart. You didn't say how much research time did you put into this?
I really don't know. I kind of lost track, and my wife would tell me every.
Do you know what date?
You
know what year you started? What date you started?
I started maybe last year, maybe around February or so, and so RocksCon was in October. But you know, I think I've been tinkering with some other stuff and some older bugs in versions that had been well since patched. So some of the original stuff that I wanted to do, I just basically had to throw out the window because, you know, I may have emailed Cisco about it and they were like, you know, this got patched, you know, 10 years ago. Well, you know, whenever. So when I did this, I actually picked out the latest version at the time of the firmware and started with that. So pretty much everything was fresh.
Right, but all the bugs is everything patched to you?
Everything is patched apart from the potential malicious firmware. So as far as I'm concerned, on the legacy firmware, they can't do anything to patch that because they don't have any trusted boot sort of sequence.
Right, but did you say that they have fixed the trusted boot thing? Are they?
Oh, they have in the new hardware.
But are they changing the way they do the signing stuff, or is the same the old style?
Well, they never did any signature verifications in the legacy hardware. So even though they had some, you know, SHA-512s or MD5s originally in the firmware, it was just checking itself.
It wasn't really used for it.
It wasn't really used like from a trusted source verifying it.
And that means that you can't downgrade any of the new hardware to the old things.
Well, I'm thinking, you know, that bug where we do the shell escape, I think, you know, that's on a signed version of firmware. So you could potentially downgrade that, but then you would have to use that firmware image as a bootloader for booting newer firmware, if that makes any sense.
Fair enough. It still feels like Cisco still has a lot of work to do to...
I like to think that they're getting better. I haven't looked at any of the new hardware stuff. The fact that you know, they have... put in sort of secure boot is a big step.
Still a bit shaky, right?
Yeah.
So, do you have any questions from the audience? All the way down there. All the way, yeah. It's going to take a while. Take this one first.
Yeah. And next one.
Mine's really, really quick, which is, do these devices also have a setting that you can do to basically override the firmware checksum in terms of something that you can put into flash or ROM?
Well, in the new devices, are you talking about? Because I don't have access to a new device, so I haven't actually looked at it. I've only got my legacy hardware.
It used to be Cisco would always build in something where you could override it if it had a check.
Right.
Just in case you had to flash the device. And
I don't know. I'd have to look at the new hardware. Obviously, in the legacy hardware, it doesn't do any verification at boot time. So essentially, all the protection was checking whether or not those SHA-1 hashes that are embedded inside the file are valid post transfer. So after you've uploaded it. So obviously you can bypass that whole step by just SCPing it to the device, and it doesn't do that. And once it's on the device, your malicious firmware is on the device, it's always going to run. There's no further checks.
Yeah.
So on the newer devices we have ASLR, right? ALSR. Would that solve the hiding the NAT thing?
On the new devices, I mean, I don't have access to the new devices, but
it should in theory, right?
Well, not really, because I mean, you've still got local access to it. So I mean, even if you just sort of grep the memory, you could see where things are. It's not like you get the protection of ASLR with the remote exploit where you don't know where things land. But because you actually have access to the running image, you can just work out where things are.
Okay. So as a sysadmin, what can I do? What should I just switch to some obscure open WRT solution, or?
I mean, basically, you got to start treating your firewall devices and your security devices as if you were, you know, locking down a server. So you just start disabling the services that you don't use. It's kind of strange because, I mean, you know, the firewall was always meant to be like the transparent sort of bump on the road that just blocked things and no one knew was even there. And suddenly they're just doing all these new features and, really getting involved in the user's traffic. So, I mean, I don't know, maybe just lock it down to what you need, as if you were, building a Linux or Windows box.
Thank you.
But the firewall has such a nice potential because it's there.
Exactly. And it's sitting right on the edge of the network.
Yeah, it's there.
And it's got access to all the traffic that runs through it.
It's got hardware. It's got software. It's there.
Yeah.
It's good. It's good. Why not use it, right? Okay, so